domain and range of linear equations in the form of graphs. So this is going to work more on notation about how to get a range, or I guess that's a bad word to use, a maximum, minimum, or just putting walls around where the function lies in the graph. You're going to do that by using inequalities. So domain and range is what we referred to in the previous section as just being your x and y, your input or output. And there's also going to be sometimes a function that is not a line, but it's more of a line segment, meaning that it terminates on two ends. You could also have array, which it terminates on one end and continues infinitely into another direction. You can see here that on the first graph that the circles are colored in. That is relevant because we can have open circles. Remember that whenever we have open and closed circles, that was used for inequalities to show open circle means it cannot be equal to that number, and a closed circle means it includes that number. So right now what we have are two of the red highlighted spots, those 2 points. Those are going to be the limits in which we're able to work with. The domain and range are going to fit in between those points and actually be equal to those points since they're colored in. So there's a way to go about doing this that makes it a little easier. Like our first thing is to look for the lowest x value. The lowest x value is going to be -2. So I could write everything is going to be greater than -2, right? Because if we look, the line is all things greater than or equal to -2 right here. So I'm going to put everything greater than or equal to -2. And I'm putting greater than or equal to because it's a closed circle first off. And the line is moving down and to the right. So that means all the numbers to the right of that would be greater. Then you can look for the highest x value. The highest x value you can see would be on the far right down there in the corner. That would be at +4. So that is a closed circle, so it's going to be or equal to. And we know that all the points on the line lie to the left of that until we reach the other point. To the left of that filled in point is going to mean less than. So x can also be less than or equal to +4. This is how you can start writing complicated domains and ranges about where two things fit together. You can write them as two separate, and then you can combine them to make it where it looks like it has 3 parts to it. So I'm going to go ahead and just take this, and I'm going to write the minimum right here. I'm going to write the maximum right here. I'm going to write x in the middle. So we said that x was going to be greater than or equal to -2. Now you can see that the inequality sign is going to eat the x, right? We can put little teeth on it right there, and it's going to eat the x. All we got to do is keep that true. It's still eating the x. Now, so it goes in between x and -2. It's eating the x. You can see for the 4, it's eating the 4, so all we got to do is keep that how it's going. And then you can see that that matches what we originally had. So that is one way to simplify and then go about combining two ranges for inequality, or using inequalities. The same thing is going to apply for the range. You find your lowest y value, and then you'd write your inequality for that, which should be -5. And then you'd find your highest y value, which would be 7. And then you would say, okay, well, all the points are above or below, and then you'd write your inequality in the same way. I included another example just to show what it looks like whenever you don't have a filled-in circle. And all it really does is create a not equal to, just creates a less than or greater than. And that just means it's not including that value. So 3 is not part of this function as far as the domain is concerned. So you can see how that slightly changes things, but it's the little tiny details that are confusing whenever you start using inequalities. So I just want to make sure to point that out.